Welcome to Change by Design, the podcast where we shine a spotlight on engineering transformation. I'm your host, Chad Jackson, and each week we dive deep with leaders driving real change in the world of engineering. From breaking down barriers to challenging the status quo to fostering cultures of innovation and resilience, our guests share their journeys, lessons learned, and actionable insights to help you become the catalyst for positive change in your organization. Whether you're an engineer, an executive, or simply passionate about making a difference, you're in the right place. Get ready to be inspired, empowered, and equipped to engineer a better future, one change at a time. Laura Eterero Hernandez, welcome to the show.
Excited to be here. Really excited to talk about this.
Yeah. So I think a good place to start maybe is to learn a little bit about your background and how you got to this point in your career journey. Like, what led you here? What got you excited about engineering? What's the story there?
Oh, great question. I will say that I definitely fell into systems engineering. I didn't start with systems engineering. I actually went to Georgia Tech for aerospace engineering, and I focused on spacecraft design. I had been flying gliders and airplanes when I was in high school. I was just really passionate about air and space. So it kind of came naturally when it came time to pick a college and a major, living in Georgia, going to Georgia Tech. And then once I graduated, I actually ended up getting a role in manufacturing for automotive, of all things. Not really where I intended to land, but it actually set me up for really good foundation for what I ended up doing in my career. So I was there for a couple of years, then I moved to Northrop Grumman and started doing cost modeling. And that's kind of how I started entering into systems engineering and doing a lot of models in general is what I was doing at the automotive company. So I ended up continuing that work and then moving into the larger system engineering organization within Northrop Grumman. And if you know about Northrop Grumman, you know system engineering is really big there. So it seemed like a good career path at the company at the time. And I kind of, it sounds cheesy to say, but I kind of fell in love with it. I liked seeing the way things integrated together at the systems level. I got a lot of experience and exposure to a lot of different systems and domains. I worked the infamous Sentinel program. That's where I got a lot of my battle scars, and turned system engineering into model-based engineering, which I was doing before, but we didn't really call it that in automotive and manufacturing. And then learned about digital engineering, which kind of has caught on in the, I'll say, recent past. And now I'm with Leidos doing more digital engineering.
Awesome. Great stuff. Good background. And aspirations, do you want to end up in management, interested in technical track, anything else that's interesting?
Yeah, I'm actually currently in management at Leidos. I'm the director of digital engineering for their defense systems sector. And in terms of aspiration, I am actually working on my PhD in systems engineering. So I'm hoping that will help me figure out what I want to do later on in my career. So I think there's still a lot of things that interest me, and especially with Leidos, they have a lot more flexibility in terms of career path than some of the more traditional aerospace and defense companies. So I'm not sure where we're going to go, but we're going to be at Leidos for a while, I think.
Okay, cool. Very good. I'd love to shift gears and talk about change agents for a little while. I think lots of people have been exposed to change agents and their involvement in change initiatives, but I'd love to hear your definition. What is a change agent? How do you identify them?
That's a tricky question. Because I found that change agent isn't a specific title or a specific role in the organization. And organizations are historically very good at maintaining status quo because things are going well. Why would you change it? At the same time, recognizing if we don't change with the times, we're not going to be able to continue making profit, getting new business. Things do change, especially in the past few years. We've seen this explosion of new technology, especially with AI being infused into everything. So, in terms of how you define what a change agent is and how that role kind of plays in these different organizations, I would say that it's less about the title or the level of in which you are in the company, but more about how do you start bringing in uh, these new technologies, these changes, these trends within your own role. And you really got to look at it, who's influencing things on a program or at the company, because it's not always the person with the title. And so those change agents are in a lot of different locations, right, within a program or within a organization. And they really are the some of the bigger cogs in the machine that is a business that are going to help bring in some of that, some of those
Yeah.
changes that are maybe they're slower to take. Maybe they're everyone's suddenly interested in something, and they're the first ones that kind of get people behind it.
Yeah.
So I feel like it's hard to really define. I do think that people who are change agents, they kind of know it and incorporate that into whatever role they're in. Sometimes begrudgingly, right?
Yeah.
But I feel like it's one of those things that you kind of know it when you're in it, but you don't know how to define it necessarily in the moment.
Yeah, I think that's very astute. I think that's insightful. I think you've touched on a lot of nuance there in what we've seen in engineering organizations. Well, let me ask you this. Do you consider yourself a change agent?
Yes. I mean, by definition, my role, right, of leading digital engineering and digital practices, within my current company, by definition, yes, I would say that I have always been trying to question why are we doing things this way? Can this be more efficient? I really, struggle with things that take a long time. Right? I'm very impatient and very stubborn, so when I feel like there's a better way to do things, I really try to advocate for those things to change, even if it's a process. This is the way we've always done it. The longer I've been in these roles, the longer I realized that at the time that the decisions were made, um, might it might have been a good decision at the time, and once the organization grew, you kind of start realizing, oh, we need to change this process, this tool, the roles, how they're defined. And that's where you need those change agents in various positions in an organization to bring those fresh eyes and say, hey, why are we still doing it this way? I know of a better way, or let me go look at options for doing this a different way.
Yeah, really insightful. Okay, good. Um, so talk to me a little bit about um, what do you think are the like success factors or facets of being a change agent? When you look at like, oh, that's a really successful change agent, what traits do they exude?
Ooh, what traits do they exude? One of the biggest traits I think you have to have if you want to be a change agent or you want to be a successful change agent, um, is really being that translator from the vision at the top to the day-to-day tactical work at the, kind of the bottom.
Mm.
And it's not easy to do that. It requires a lot of soft skills that you are not taught in school. It requires a lot of on-the-job training that you can only get through a certain level of experience and certain opportunities. So I think that's one of the biggest common factors around the people I would call change agents, even in my own organization, is they really can take that vision from the CEO, the CTO, their manager, whoever it is that's setting the vision for the organization, the team, no matter how big or small, and are able to make it happen and help people understand how do we get there.
Good. Yeah. No, that's really interesting. I never, we've been doing podcasts like this. We've probably done two dozen or so now. And these are the same questions that we ask everybody. But that's the first time I've heard like translating a vision down to tactical day-to-day, activities and tasks and how you do things. That's the first time I've heard that. And I think that's dead on. I think that's something we've missed so far. Because you certainly won't see an executive come down and say, okay, you press that button and then you take this thing over to this other role. But they have a vision about how they could see it being executed. What would you say for you is most satisfying or fulfilling or dissatisfying or unfulfilling about being a change agent? Like, what's the pros and cons here?
Oh gosh. I think I'm sure if I thought about it for a while, I could probably give a pretty extensive list of the pros and cons. I'll start with the pros. I think one of my favorite things and why I've stuck with systems engineering and kind of put myself in these positions of change and integration within an organization is because I really enjoy seeing things coming together and achieving that vision, because some of the times it's stuff that we know it when we see it, but nobody knows how to get there. And so charting that path to get there, I find it very satisfying, right? And people opening their minds to testing things out and trying things out, and it's okay if we fail, and you kind of start seeing them shift themselves and how they think about the problems. So I would say that's definitely a pro from like why the job is so satisfying. There's also the pros that it's typically, whether we like it or not, it's typically a pretty high visibility role that you end up being in, because you have to talk to so many different people. You have to be very interdisciplinary in your approach, especially with digital engineering. I tell people it has engineering in the name, but it's not. Yeah, the physics didn't change, and the way we do engineering didn't change. It's what we're doing around it to make it happen. And so I find that kind of very fun, because you get to talk to people that you would never get to talk to in other roles, even if you're kind of lower down in the organization. I would say that the cons are that it's new enough, and change, the how rapid change is coming into these organizations. You hear about disruptors like Anduril and Palantir and OpenAI. They are bringing stuff in very quickly, and so the con is that humans don't like change, and getting people on board very quickly can be difficult, even if you have support from the top, even if you have funding for the work. It can be very, very difficult to kind of bring people on and get that momentum going for the change to take effect and then last, right? Because the sustainability of that change, I think, is right now some of the challenges with doing digital engineering or digital transformation or model-based engineering.
Okay. Wow. Yeah. A good spectrum. Pros and cons. Let me ask, so it's interesting. We just conducted a research study around change agents and MBD and MBSE. And what we found, so we asked questions around what responsibilities do you fulfill? And what we're finding is there's this huge overlap for change agents with IT responsibilities and then day-to-day design responsibilities. And there's very few people that are exclusively a change agent or exclusively in IT now. There's this huge overlap between them. Can you take a second and talk about, like, if you're going to be a change agent, are you given some, I guess, space and time to do that job? Or is it a add on top of everything else you're doing? Can you talk a little bit
Mhm.
about that?
Yes. It is certainly an add on top of everything else that you're doing. And
Mm,
I find that it's kind of rare. And we're pushing for this more and more where we have people who are actually dedicated to driving the changes in organizations. We're getting to the point where we have to go work with our business development teams and tell them, you have to bid for these roles. They have to be full time if you want them to be effective.
yeah.
And that's kind of it's what you're saying about the overlap is very, very true where a lot of these things haven't been done before or haven't or we know what not to do, right? We know what won't work. So having that responsibility where you are both the one designing the work and having to be the sysadmin on the software application so that you can do your integration of between tools or between data sets and data repositories. I mean, it ends up I think there's an expectation to have not just have those skills and be able to learn and apply them, but it is definitely one of those, like, unpaid labor add-ons that, you fall
Yeah.
into, and that, and it can certainly make or break, people's, careers or if they want, if they are not sure they wanna be in a certain type of role or discipline, it kinda starts weeding people out because that is basically how we have to do work now. We have to
Mhm.
be just as software savvy as we are, hardware savvy.
Yeah. Yeah. No, I think that's a great point you bring up. I think that is a modern reality that it used to be you could have your process and you could use email and documents and they could be detangled. But I think with today's technologies, they're so ingrained in the process and the steps that it's really hard to detangle them. So it requires a new set of skills and experience to be successful. And if you're going to come up with a new process, you better also you better know the technologies as well because they're
Yep.
intertwined.
Yeah, absolutely. And it's funny because I remember an example of this on one of the programs I supported where we wrote up the whole program was supposed to be using Jira to manage their work, and we had agile release trains. It was a very big program, so we were doing scaled agile framework. We had dedicated scrum masters, agile coaches. I mean, the whole, we went all out. And we had our team developed a script that would essentially generate dependencies and create the issue in Jira and assign it to the person. Um, and then we found it wasn't working because the team, the cost analysts that were running IMS and whatever their software was, they wouldn't log into Jira and
Oh,
look at tickets. And we said, why did the program leadership ask us to make the script if this team wasn't going to get into Jira with us and work, with us and collaborate? And so it became a very interesting challenge because the engineers don't want to use the cost analyst tools. The cost analysts don't want to use the engineering tool. And they would tell us, they're like, that's an engineering tool. Why would I even put it on my laptop? Um,
mm,
and so that's where being that bridge for people and between teams became a very evident that this is a full-time role. Because you have to know just enough about everybody's business to make that connection for them.
really interesting. I think that's a really good takeaway for executives with these visions that are driving it down. You need to resource this kind of role, especially, I mean, the bigger the scale of the change, the more you need a specialist to really help drive the change. So,
Absolutely. And you can see, like, the idea was there. It was a good idea, right? Where the analysts are not gonna learn we don't wanna put them through the training to make Jira tickets so we can just generate it for them, but they won't even log in to read the the request, much less
Yeah.
fulfill it. So, so the idea was there, but the decision came from the top, and it's something that we didn't really anticipate at the time.
Yeah. Gotcha. So real quick follow-up on that. And you don't have to tell me what program it was or anything like that. I know we don't want to delve into that level of detail, but um, was that hardware and software for that program that you used
Yes,
Jira
it
on?
was.
Okay. So that's really interesting. I see more and more programs leaning away from traditional systems like PLM and more into, new emerging tools like Jira and Slack and Asana and stuff like that, are you seeing that same trend or is that just me?
Um, I have seen people try, not successfully. So,
Okay.
I've seen, it's funny because I get asked what tool can do XYZ. They give me a scenario or a use case, and they ask me, "What do we have a tool that does this?" And I ask, "Well, what tools are you using?" And oftentimes, the tool that they're using is the one I would recommend for that work, and people are not fully utilizing it. And so, when you take, if you put Slack on someone's computer and you expect them to use it, but they still have access to email or access to kind of the old way, right, of doing things, it
Yeah.
doesn't seem to take. So I have heard of that, especially startups. I think the cost benefit is there for startups, but for the larger organizations that I've worked for, some of the legacy companies, they haven't been successful in implementing that type of adoption.
Mhm. Gotcha. Yep. Okay. Good insight. I appreciate that. Um, let's talk about system engineering. Let's shift gears again. So I'm curious. You can either talk about specific companies. You don't have to be specific, but um, it would be good also just at the industry level. Adoption of systems engineering, is it continue to grow? Are you seeing it in certain types of companies? How's it going with suppliers? Mm, and yeah, I guess let's start there.
Sure. I will say that system engineering as a discipline, I actually hadn't really heard of it until I got into aerospace and defense.
Yeah,
Um, and you'll talk to people in certain companies, like SpaceX, for example. They don't have system engineers by title, but when you ask certain engineers, okay, what do you do in your role? It is system engineering. And it's kind of part and embedded with some of the other things that they do as the responsible engineer for, that subsystem, the requirements threads. I have found that in some of the legacy companies that have the system engineering, I'll say job code, um, a lot of those people end up being just requirements developers. They don't really seem to pull all the way through the life cycle and follow the systems V. And I know part of it is coming from the fact that some of our contracts take decades to do. So people don't have
sure.
the opportunity to move from one stage of the life cycle to another, and have that experience. And I have found some of the most successful system engineers are people who have come from those other disciplines, whether it's manufacturing or mechanical engineering, people who have experience developing and seeing the testing and how the requirement decisions up front impacted all these other things down the road. And then they get into systems engineering and they have a lot of good insight into, the shall statement should be written this way or decomposed that way. Um, but it's kind of sad to see so many people only get exposed to one portion of it,
Yeah,
because when you get to do a lot of the different milestones, a lot of the different portions of the life cycle, even if it's with different systems, you start seeing the connection and the integration and why system engineering kind of exists as itself.
hmm good, good. Okay. And then uh, let's talk about it from a staffing perspective. Are you seeing formal roles, a lot of formal roles that are system engineers? And the people that get pulled into those, and I think this ties back to your background, did they come from, there are some universities that have system engineering degree programs, but there's a lot that do not. And people get pulled into system engineering for mechanical or electrical or software. What's your experience been there? Where are these roles coming from, whether they explicitly know they're filling that role or not?
Mhm. Yeah, we do hire straight out of college, especially like you said, some universities do have system engineering and they do teach it as its own major. Um, I have found that it does kind of come from um, all sorts of backgrounds. I would say if somebody has experience with like chemical engineering, though it's very process heavy. So they actually make really great system engineers because systems is very process heavy. So and same with manufacturing, right? Things have a flow, they have a process. There are certain things that have to be sequential and other things that can run in parallel. So they tend to have a good foundation as well. Um, for me personally, I have I'll say a controversial take, which I don't actually think we should have system engineers that have less than 5 years of experience doing something else because it
Ah,
really it's almost like the very theoretical ideal practice, and then you throw somebody into a program and now you have to care about budget constraints and you have to mitigate risks and you have to meet with all these teams who have their own list of priorities that don't match with yours.
yeah.
So I feel like people do struggle straight out of college. And that's not to say they're bad engineers or anything. It does make me question how realistic are the projects and the experience they received before coming in as a full-time systems engineer.
Mhm. Yeah.
And typically we pair people with uh, more senior engineers for that reason, right? It's a lot of on-the-job learning if you're going to stay with systems engineering from the start.
Yeah. Okay. All right. Got it. No, I think that's interesting. I mean, you definitely have to pull across domains if you're going to be a systems engineer. So at least having some exposure to that before you start doing the job seems pretty logical, pretty rational. Um, Talk to me about the process. Some companies realize that, okay, system engineering is kind of a separate phase. You need to go through that before you get into detailed design for each individual domain. Have you seen companies dedicating a phase of the development cycle to systems engineering? Or if it's new, do they say, I'll just jam it in and then every other phase shrinks too? Like, how's that work?
Um, yeah, so I won't mention the company or the program, but we have seen programs that do not bid in any systems engineering, and
Ooh.
the amount of rework and cost impact is very noticeable to the company. I had a program that ran $68 million over on a firm fixed price
Woof.
contract because for their first phase they did not do any systems engineering, so they had to jam it in. So that was a good lesson learned as
Yeah.
to what we could have done because if we had bid, I think it was only like 2 million on top of that was had been priced out just for that first phase to set up that system properly,
Mm.
at at the abstract levels, it would have saved us $68 million, right? So we kind of have that point to that unfortunate data point to point to, and there's certainly other programs that have had similar issues. So I wouldn't say that it's its own phase. I would say
Okay.
that system engineering does have to be done up front very heavily, and then you kind of tailor it off when you get into the detailed design because at that point the engineers have accepted the allocated requirements. from the system level down, and then they can kind of take it from there. And that's where you see companies that are very manufacturing heavy, they don't have dedicated system engineers. And then you start seeing them come back when it comes to the verification, validation, the testing, the test plans that get created. And so it's, even though the systems V is developed for the full life cycle through deployment of and fielding of a system, most of the work, I would say, is upfront. And that we know for a fact, we've seen the studies, the research, we have these anecdotes that say this is really worth investing in
Yeah,
from a business standpoint.
that's great. Great perspective. I think that's really great. Let's talk about MBSE. Let's switch and talk about that. So I think a good baseline would be to talk a little bit about DBSE, or document-based system engineering, versus model-based systems engineering. Like, how would you assess the state of at least the companies that you've been in? Again, you don't have to be specific, or the industry overall. Like, where are we in this transition from documents to models for this stuff?
Great question. I feel like at this point we are in that really awkward phase where enough people understand how to do model-based engineering, but we are still being asked to deliver document-based.
Ooh,
And in defense, we get contracts from the government, from the DoD or DARPA or whoever the customer is, and they have these. They call them description. I think it's like description something document. It's basically it's a DID. I forgot what the I stands for, but it explicitly calls out how to format certain documentation and certain deliverables. And we've had to push back and say, you have this model, you have this dynamic model, and you're asking me to strip all the relationships out and put a screenshot with a blurb on it. You're stripping the model of 90% of its usage, right?
yeah,
And so we're seeing a bit more of we're seeing the customers catch up, and we're seeing all future programs especially are doing more model based than document based. But when I first started in doing MBSE back in I think it was like 2016, 2017, we had to create these macros in Cameo that actually spit out document generated. Right, we would ask the teams, "Give me your template for this document. What's the did say?"
yeah.
And it would spit out the information. So it was almost like doing double the work, and we had to advocate and negotiate, right? It was contract changes. It's all contractual language that we have to stick to. And so even if the customer verbally agreed to it, we still had to go through the legal process
Legal
to make those
process.
changes
Yeah.
and be able to deliver what we would call native file, model files, right? If it said contractor, whatever the contractor format was, that was like the golden ticket to be able to deliver this model and actually use it, because everybody was still relying so heavily on the document, and those documents became the source of truth for everybody. But documents are stale, models are not, right? So that's kind of we're in that kind of awkward phase where more and more people are seeing that value, and more people want it to be model based, including our own customers. And the legal side of it has to catch up, and is starting to catch up, which is really nice to see. So I predict that hopefully in the next 5 years, everything will be model based, and our customers will be caught up enough on how to navigate the models themselves, because that was a whole nother reason why there was pushback there. They didn't know how to find the data they were looking for, so they wanted it in that document because that's what they were used to seeing, right?
Yeah.
But I'm hoping that we get through this kind of in between state that we're in right now quickly.
Yeah, no, that's really interesting. And I think it makes me think about long-term archival of those types of
Mhm.
models and those information. Especially in the context of SysML 2.0 coming out, and lots of people being very excited about that and wanting to make the transition. Have you all, at least, in your experience, have you seen some good solutions for long-term archival, at least internal to your companies that you've been in?
Um, Unfortunately, no.
Okay.
It's something that I know some of the, in the community of practice, we talk about it in terms of the, um, say the subject matter experts. We know that that's on the horizon and something that we need to tackle. In terms of the company itself providing us the resources to do something like that, we haven't even broached the conversation.
Yeah.
Because the business side is, they have different priorities, they have different focuses, and so until you can tie it to their understanding, and it's that making that translation, right, of this is why model-based is important, or this is why we need to archive these models in a way that preserves its integrity, we're really not gonna I don't think we're gonna get anything anytime soon, but we do have
Yeah.
people who are passionate enough that they know it's gonna be an issue, and they will create something. Engineers are very good at solving problems one way or another. Um, and we have
Yeah.
had lots of grassroots efforts like that, especially at where I'm at right now. We have lots of, homegrown things that turn into an enterprise offering because somebody said, we're going to need this someday, and I'm going to tell everybody about it until it gets used enough that it becomes an enterprise thing. So,
Yeah.
um, yeah.
Okay. All right. Gotcha. Um, let's talk about a comparison of model-based systems engineering versus DBSE, document-based systems engineering. What have you seen as like tangible advantages and benefits? Like, how's that manifested within a program?
When you say manifested, you mean like the differences or the
Now, how's it
advantage of model versus document?
how's how does it show up in terms of time and money? Um, the
Hmm.
program's fiscal health. Mm, Yeah, that kind of thing. Bottom line stuff.
Oh, and so I have another story for you. So on a program that we were very new at utilizing models to review the actual design of the system, and so we had to give everybody, including our customer and their CETAs, which is a um, system engineering and technical advisor.
Yeah.
It's a short. It's a defense specific thing. And we kinda had to give them a crash course, a 101 on how to read the diagrams and models, right? If you have, like, Sparks or, Cameo, we had to explain that every line, every, box, every word is code, and they don't see it that way, right? They see a diagram, and we have to explain the diagram's not the model. It exposes the model for us humans that need to make those decisions. So we kinda got them through that phase, and then we started using the model to do our design reviews. So our CDR, our PDR, our, system requirement review, our functional requirement review. We were able to do all of that through the model. And because we were able to sit them in the skiff with us, walk through it in detail, answer questions live, we left with our exit criteria was all green, and they had 0 actions for us, which is unheard of. Usually you end up with actions, right? Because it's just PowerPoint slide after PowerPoint slide, and
Yeah.
they're not seeing what they need to see to say, "I feel good about this to move forward in the next phase of the program." And so that was a big win for us, and to show not just the customer that we can do this through model-based documentation and communicate through the models. It's live, it's dynamic. We can add things, change things live with the customer right there, versus the very long process that we have right now, which is we deliver things. The customer has, like, I think it's 10 business days to review everything, send back questions, in a spreadsheet, right? It's like an Excel spreadsheet. We have no idea what section they're talking about. So we have to send back our questions and we have 5 days to do that. I mean, it's a very, when it comes to the bottom line, like how much time did we save? We saved weeks, if not months of work. We saved so much money because we didn't have to submit the engineering change requests. We were able to work with them live there and just with a click of a button, make the right changes. So it can be very, very powerful. I've seen it be very successful, which is why I'm so passionate about doing model-based systems engineering, because it makes your work so much easier, and you get to do the fun part, which is the designing the system and integrating the system and testing the system, right? So it's a big shortcut that I don't think a lot of people have tuned into yet.
Yeah, no, that's great. I mean, I never thought about eliminating deliberation that can go on for weeks and weeks and weeks as an advantage, but I think that's outstanding. Let's talk about disadvantages and detriments. And I'm a big fan, make no mistake, I'm a big fan of MBSE, but no IT solution is perfect, right? I mean, there's going to be ugly spots here and there. Can you talk a little bit about, like, in practice, any challenges around MBSE?
Absolutely. So other than the learning curve with the tool, we found that same program where we were able to successfully do the walkthrough and clear our PDR with our customer with no actions. We actually had a chief engineer. So usually when these big milestones like the PDRs, the CDRs happen, there's typically a change in leadership management. It's just kind of the nature of how these programs go, because it's been years. People want to get to that milestone, say I supported, I did it, and move on, because we're now moving into a different phase that they don't have necessarily the experience to run. So we got the new chief engineer, and he was very supportive about model based. He was like, let's use the model. I wanted to incorporate it into our engineering review board cycles. It was fantastic. However, and we didn't know this at the time. Lots of lessons learned from doing this for the first time. He wanted everything in the model. And he would ask, like, is this something we can put in there? Is this something we can put in there? And so we ended up having to buy, I think, like hundreds of licenses, put every engineering team through the training, because we thought they're going to be working in the model with the system engineers. That was a bad idea, and we didn't. So we ended up having to kind of ask the question, should we put it in the model? Because at the time, nobody had thought it. We said, this thing can handle all sorts of data, and put in those relationships. And so it turned into a fight of what should go in there at what level of detail, right? There were COTS products, commercial off-the-shelf products, that they were asking us to design in detail. And we were pushing back saying, why would I model something that I'm going to buy? I don't care what's in there.
Right.
You don't need to know that. If it meets the requirements, it's a black box to us. We don't care. And we had a team that was like, we have to go down to the harness, like every pin, every wire, every circuit. I mean, so that was kind of a con, right? Is yes, these models can be very powerful. MBSE can be very a powerful tool to make decisions, but we kind of went too far the other way. And at the time, we didn't know it. Now I know better, right? We learned from that, and we can guide and instruct our chief engineers, our chief architects, our engineering teams and leadership on our programs to say, hey, this is where the benefit curve kind of ends. Don't put any more money or effort into it.
Yeah, no. Fascinating. Just this week, I was in the middle of a LinkedIn debate that was focusing on, and of course, it comes from software providers. They're like, everything should go in the system. And like,
hmm
no, that's why humans are also involved. That's why, they talk and communicate and do stuff offline. And so, yeah, I think that debate will rage until the end of time. I don't think that'll be ending anytime soon.
It's funny you say that because we actually had that conversation at one point on the Sentinel program where you have two people in the bunker, and they wanted us to model what they were going to do. And I asked the question, how do you model one human turning to the other human and telling them something? Because that's never going to change, right? We don't need it to
Right.
be in software. We don't need a hardware thing. So how do you model human things that happen that show? Because we had to prove, right, we're satisfying this requirement. But the solution was they literally just talk to each other, sitting next to each other all times. It's kind of funny that you had that debate because it's an interesting problem from an MBSE standpoint.
Yeah. Yeah. Well, I think there's always, some people that are idealistic and think that, yeah, everything should go in. And then there's the realist that says, no, that's
Mhm.
not feasible or reasonable. Although, so I think this leads to another really interesting question, which is about AI in code-based things. So, we're seeing the use of AI explode in software engineering because
Mhm.
it's text-based. AI right now is really, really great with text-based things, and it can really enhance the productivity of developers. And and I hadn't thought about this until now, but this whole concept of MBSE, it's all just code underneath this pretty diagram. So it seems like there would be an opportunity to leverage AI to automate some things, be an intelligent actor as part of the development process. Again, I'm not asking about any particular company that you've worked for, but have you seen anything along those lines progressing that is an interesting application around AI to MBSE?
Oh, absolutely. I've seen several trials of, how long does it take a person to get this far in developing a model versus AI when you train it. And it could cut down the amount of work very quickly, especially when you have
Right.
some, I'll say a more generic model that you can start off with. There's certain things that we know have a lot of regardless of what kind of missile it is, there's specific things that are going to be part of a missile's behavior, no matter what type of missile it is or aircraft, right? So there's a lot that we can basically jumpstart a model from AI, from an agentic AI, and cut down on the
Yeah.
time, and have people and engineers kind of pick it up from there, almost like a model template or a reference architecture that we've seen before, but somebody had to make that. Um, and so AI definitely has the advantages. I think part of the challenge to get us there is going to be having enough data, because MBSE has been around for a long time, but actually collecting all of these different models and being able to give the AI the right data sets or whatever, however they train. I don't know enough about AI to say. I think that's part of the challenge because especially companies like that model is proprietary data. They're not gonna give that up. And so I think everyone's maybe trying to create their own agentic AI for MBSE.
Gotcha. Okay. All right. Well, that's promising. That's very, very exciting. Well, thank you so much for your time today. Really appreciate it. I got one last question. If you could redesign or re-engineer anything, you could wave your magic wand. What would you do that with? A better
Oh my
mousetrap
gosh.
or our economic system or anything, right?
Um, oh my gosh, that's such a fun question because that's one of the that's actually one of the things I've done in my PhD program is everything's a system, right? Like economies are a system, our bodies are a system. So I feel like it's hard to pick a single thing. But I actually think that there's like for me, infrastructure, like the roads in the US is something that I actually think could use a reboot to make them more efficient. I also get really lost, like I'm really bad at navigating, so that might be why. But if I could kind of restart some system, it would probably be uh, the way certain roads are,
Yeah.
bridges, certain things like in our like infrastructure in the US are designed just because it's very um it was very piecemeal over time as cars evolved, and then the interstate system was developed, and right, so it's and even my PhD is actually on I'm looking at the power grid in Texas, and how it can kind of be recreated so that it can last over time longer. But it's yeah, so I have a kind of a that would be the one. I think that if I could wave a magic wand and kind of like better develop our infrastructure in the US, I think that we would have had self-driving cars by now, probably.
Probably. Yeah.
Everybody would be on a train, maybe. I don't know, but it would be that.
That's a worthy cause. I think that's a really, really good one. Yeah. Thanks so much for your time today. I think this is a great conversation, really good insights on MBSE and systems engineering and change agents. Yeah, thank you so much.
Yeah, thanks for having me. This has been a really great time for me. I appreciate it.
Thanks for tuning in to today's episode. If you enjoyed the conversation, make sure to follow or subscribe on your favorite podcast platform so you never miss an update. We'd love to hear your thoughts. Send us a message, leave a review, or join the discussion on our social media pages. Until next time, take care and talk soon.